In chapter 6, the next topic, that is the topic related to second exercise, is expectation and variance. So, what is expectation? The expectation of a random variable is the average value of the random variable, and it can also be called as the weighted average. The weights used here will be the corresponding probabilities. It is calculated as sigma xipi for a discrete random variable. Sigma always stands for sum. Xipi means every x is multiplied by its corresponding probability, and it is also calculated as integral minus infinity to infinity x into fx dx for a continuous random variable. This minus infinity to plus infinity will be replaced by the lower and upper limits of the corresponding random variable. So this is the general form, and according to the sum we have to take the lower limit and upper limit of the concerned random variable. So, and variance is a average of the squared deviations of a random variable from its own arithmetic mean, that is from expectation of x. So, as per the definition, it will be expectation of x minus e of x the whole square. And instead of calculating the deviations, there is a direct method which we use in our practical calculations, and that is actually v of x is equal to e of x square, expectation of x square minus expectation of x the whole square. The expectation of x square will be calculated as sigma xi square into pi for discrete random variable, and integral minus infinity to infinity of x square fx dx. So instead of x we use x square there. So this method will be very easy for calculation purposes, but actual definition is this. This if you simplify only you get this. And other than that, what I want to discuss in this video is the property. Expectation and variance, they have certain properties, and sometimes you get it as a theory question in your question paper for 2 mark or for 3 mark. So first is properties of expectation. Expectation of A is A. Here A stands for any constant. Expectation of a constant is that constant itself. And E of A into x is A into E of x. The variable can be taken out. So expectation of 3x will be 3 times expectation of x, like that. And then E of ax plus b, it will be A into E of x plus b. So same concept we apply, E of ax plus E of b. E of b is b itself because b and a are all constants. So that is how we get this answer. And if x is greater than or equal to 0, you can say expectation of x will also be greater than or equal to 0. As you know, expectation is a direct average value. So you must remember one thing, when you calculate an expectation, it has to be a value in between the least value of the variable and the highest value of the variable. It is not a probability, so it need not be between 0 and 1. Actually, the probabilities and even the capital Fx, that is the distribution function, they are all probability values. So they all have to be between between 0 and 1. Therefore, whereas this is not like that, this is not a probability, this is actually a average value. So its value can be more than 1 or even less than 0 according to the values of the variable. So it's only an average. Now we see the properties of variance. Variance has a following 3 properties. Variance of a constant is 0, because variance means measure of variations. A constant will be a constant all the time. There is no change in its value. So variance of a constant has to be 0. Variance of ax is equal to a square variance of x. And variance of ax plus b also will be automatically a square variance of x, because variance of ax plus b will be interpreted as variance of ax plus variance of b. Variance of b is 0, therefore it is a square variance of x.